Guys, Mr. Bowman here. We're looking at 2.7 calculus methods external in this video, and we're going to be focusing on all the merit questions from that 2018 exam. So I've pulled them all out. They're on the website. So we're starting at question number 19 on the website. Question number 19. Reading through the question, a rectangle has an expanding area, and at all times the length is 3 times the width. Find the rate of change. Rate of change of the area when it has an area of 75 meters squared. So I love seeing that phrase rate of change. Straight away, rate of change and gradient is the exact same thing. So let's start off by drawing a diagram. So there's the rectangle, and we've been told the length is 3 times the width. That means if this here is x, that there is going to be 3x, and the area equation will simply be 3x squared. The next bit's a bit tricky. Most of us are going to think, well, let's get into differentiation. But before we do that, we've been told about the area of 75 centimeters squared. So we know the area is going to be equal to 75. So we're going to substitute that in. 3x squared. So we're then going to go divide by 3, divide by 3. 25 is equal to x squared. X will be equal to plus or minus 5. X will be equal to positive 5 only. We're ignoring negative 5 because you can't have that negative measurement. So we're interested in this particular shape, which has an area of 75 centimeters squared when x is equal to 5. We now need to differentiate this. So we're now going to go, well, the area is equal to, well, the area dash is equal to 6x. And we know that x is equal to 5 because we calculated that before. We're going to put that in. So that's going to be 6 times 5. And that there is going to be 30. And it's going to be really, really tricky. The units for these questions are an absolute headache. But that 30 relates to the area, which is centimeters squared, per the thing that's changing, which is the x variable, which is the length of the side, which is in centimeters. So we are now looking at question number 20, and the derivative of a function is given by f dash x is equal to that. The graph has a local minimum of 0,5. We've been asked to use calculus to find out the maximum. Let's start off by jotting down the gradient function. And the first thing I'm noticing, so we've got a quadratic as the gradient function, which means there's going to be 2 answers, which makes sense because we've been told about the minimum, we've been asked about the maximum. So let's investigate the 2 answers. Because we're looking at the turning points, we know that f dash x will be equal to 0, so we're going to substitute that in. 0 is equal to negative 3x squared plus 12x. I don't like having a negative 3x squared, so I'm just going to move everything to the other side as opposite. So 3x squared minus 12x is equal to 0. I'm now going to factorize, so that's going to be 3x. X minus 4 is equal to 0. The first answer is going to be 0, and the second answer is going to be 4. And that makes sense. x1 would relate to this minimum, and that's confirmed by the 0 in the x place for the coordinates. Now have the x value for the maximum. The only issue is I don't have the y value. And to find the y value, I need to start looking at the original function. So I need to integrate. So I need to find out what f(x) would be equal to. So integrating this function, it's going to be negative 3 divided by the power plus 1, x power plus 1 plus 12 divided by power plus 1, and then x power plus 1, and then plus c. Simplifying that, that's going to be negative x cubed plus 6x squared plus c. And on this particular function, I already know a point, 0,5. So that tells us a bit more information. So I know that x is equal to 0 and y is equal to 5. I'm going to substitute them both in. So 5 is going to be equal to negative 0 cubed minus 6 times 0 squared plus c. All the zeros are multiplication, so they're gone, which means c is equal to 5. and that tells us our original function in its entirety is going to be negative x cubed plus 6x squared plus 5. Now the next thing is I've got the x value of the maximum or the other turning point. I'm going to substitute that in to find out the y value, and that'll give me the y coordinate for the maximum. So f of 4 is going to be equal to negative 4 cubed plus 6 4 squared plus 5. We're then going to go ahead and simplify that. So negative 4 cubed is going to be negative 64. 4 squared is 16. 16 times 6 is 96. So plus 96 plus 5. Put that all together, we're going to get to 37. So we found the value of that. Let's simply say, therefore, maximum is x is equal to 4, y is equal to 37, or 4, 37. Now looking at question number 21. Straight away I'm liking this question. Haven't even read much, and I've seen that word maximum. I know the gradient's equal to 0 at a maximum. But let's have a look. So a skyrocket is projected into the air so that after t seconds it's measured h meters. Here's the equation. What is the maximum height of the skyrocket? So we'll start off by writing down our height function. That's going to be 39.2 t minus 4.9 t squared. Now that was meant to be a 9. So first thing to note, the numbers are particularly annoying, so make sure you're using a calculator, not making any silly math errors. But what we're going to do is we're going to differentiate this, because the gradient or the height at that particular point will be equal to 0. So we can go ahead and solve for it. So when we differentiate, we're going to get 39.2 minus 9.8 t. And as I said, I know that the derivative will be equal to 0 at that particular point. So 0 will be equal to 39.2 minus 9.8 t. 9.8 t will be equal to 39.2 divided by 9.8 divided by 9.8. T will be equal to 4. So what that means is it will be at its maximum after 4 seconds. A lot of people stop there, but you've been asked about when, you've been asked about what the height is. We now need to substitute this back into our original function to find out the height in meters. So height after 4 seconds will be equal to 39.2 times 4 minus 4.9 times 4 squared. And here, definitely plugging that into my calculator, and I'm getting 78.4 meters. And that there had a 1 decimal point rounding. Now, looking at question number 22. And it is one of those questions where you've been asked to sketch the function. So the first thing you need to know is which function do you have, which function you're trying to draw. We've got the gradient function. We're trying to sketch the original function. This process would often involve integration. And what we can see is that this here is a positive parabola. So an example would be x squared, or f dash x would be equal to x squared. If we integrated that, we would get some kind of cubic x cubed. And x cubed is a positive cubic. So that's one feature we need to be aware of before we draw that function. So that's a positive cubic. The other one, pretty easy. We've been told about the point 0, 3. And the third point, we do know a bit of information about the turning points. And that's because f dash x is equal to 0 at those. So we can see if we go back to that, that's 0, which means negative 2 has a turning point and positive 4 has a turning point. So the turning points, x is equal to negative 2, and then x is equal to positive 4. So if we think of a positive cubic, it normally goes kind of up, down, and then up again. So we're looking for that shape with the maximum sitting directly above negative 2, and the minimum over here sitting directly below negative 4. And we do have to be careful. It has to go through that point 0,3. So let's plug in, let's get rid of that sketch. Let's get rid of, or start off with 0,3. So 0,3 is up here. So that means we have to have a maximum kind of sitting up here somewhere, just making up the maximum and the minimum points roughly, and then maybe a minimum over here. And what we're going to do is our function is going to start by going up, and then it's going to go down through the point there. It's then going to level off, and then it's going to go up again. So a bit of a headache, or a bit annoying to draw at times, but we can see all the functions. We can see it's a positive cubic. We can see it goes through that point 0,3, and we can see the maximum is directly above -2, and we can see the minimum is directly above or below +4. If you have all three of those features, you'll certainly get your merit marks. The graph doesn't have to be drawn perfectly, like mine looks pretty terrible, but good enough to get the marks. We are now on to the very final question, or the merit questions. Question 23 is the last question from the 2018 exam. We've been told that a school is selling tickets for a drama production. The revenue can be modeled by that equation. We've been asked to find the maximum possible revenue. And then just a reminder that selling the tickets, or the selling price, is P. So let's jot down our function. So the revenue in terms of the price is going to be equal to 40p, and then in brackets 29 minus 2p. So the first thing I need to do, I'm thinking maximum, so I know r-p will be equal to 0, but I need a gradient function for that. So I'm going to expand my bracket, which gets me to 1160p. Always use a calculator to double check these in exam, minus 80p squared. So just a reminder, I knew at the maximum r-p is going to be equal to 0 at the maximum. So we're going to need to differentiate r-p will be equal to 1160 minus 160p. I'm now going to substitute to find out what that value for p will be. I just realized I don't need that square there, so we'll get rid of that. 0 is going to be equal to 1160 minus 160p. 160p is equal to 1160. We're then going to go divide by 160, divide by 160. P is going to be equal to 7.25. So what this tells us is each ticket will cost $7.25. So a lot of people are going to stop there thinking that they're amazing mathematicians and that they've got their merit mark. And while you displayed some really good maths, you didn't actually answer the question. We've been asked about the maximum revenue. And the revenue is the R part of our equation. So what we need to do is we're going to substitute that value into our revenue equation to find out the revenue if we sold them for $7.25 each. So the revenue, if we sold them for $7.25, is going to be equal to 1160 times 7.25 minus 80 times 7.25 squared. I'll definitely be using my calculator at this point in the exam, and when I do that, I get $4,205, and that there would be the maximum revenue, and that's there is what would secure me my merit mark. If you got this 725 and stopped, you're probably going to get achieved, but that last step, maybe the easiest part, gets us the merit mark. So that's the last question from this video. Thanks so much for watching. Let's keep practicing.